Hey Algebra 2, today we're going to learn how to solve rational equations. So in the past we just were simplifying, but today we're going to get an actual answer. So the first thing that you have to do is find the LCD, so that stands for least common denominator. And if you had if these were your fractions, so some kids were understanding it better. If you had these three fractions, focus on your numbers first. So between 5, 3, and 2, what would be their common denominator? So it's like you're counting up by 5s, counting up by 3s, and counting up by 2s. What's the first number you would come to? And so that would be 30. And then if there are variables, it is always your biggest exponent. So here between 4 and 2, focus on your numbers first. The LCD would be 4. And then there's an X and there's a Y. So it is your biggest exponent. So when we start solving, the first thing you're going to have to do is look and see, do I need to factor the denominator? So on number 1, sorry, that's number 1, you do not need to factor the denominator. So I have denominators of 5. This X has an implied denominator of 1. And then that one has a denominator of 10. B, C, D, E, F. All right, so step B is to find the LCD of all your denominators. So what is the LCD of 5 and 10? So that would be 10. Step 3 says multiply each side by the LCD. So I'm going to multiply every single term by 10 or 10 over 1. So since you have 3 terms here, you have to distribute that to all 3 of them. So I'm taking 10 over 1 times 1/5, 10 over 1 times x over 1. Bring down your equals. 10 over 1 times x over 10. All right, so we basically have 3 multiplication problems. So if you focus on the green circles, so it's everything in between a plus, a minus, and an equal sign, we're going to multiply these fractions straight across. So 10 times 1 is 10, 1 times 5 is 5. Bring down your plus. 10x is just 10x. The 1 times 1 in the denominator, you can ignore that now. Multiply straight across here, so 10 times x is 10x, and the denominators 1 times 10 is 10. Step 4 says you need to cancel both sides. So when I multiplied by 10, I was multiplying so that I could cancel and not have any fractions anymore. So 10 divided by 5 reduces to 2. Bring down your plus 10x, and then the 10s cancel each out, and that equals x. So now I'm just going to do algebra here and solve for x. So subtract the 10x over, 2 equals negative 9x. Divide both sides by negative 9, and x equals negative 2/9. Number 4, we're going to rename that number 2. All right, so I want the LCD of x plus 3, 6, and 18. All right, so if you have a term with a plus or minus sign, you can't break that up, and that can't be considered as part of the numbers. So 6 and 18. So 6 divides into 18, so that is going to be my LCD. I'm going to multiply every single term by 18x plus 3. You feel free to put it over 1 because it'll help you line up your numerators and denominators. All right, so I have this first fraction. So I'm going to keep all the numerators together. So I have 4 times 18 times x plus 3 over x plus 3, that existing denominator. Bring down your plus sign. When I multiply my numerators, I have 5 times 18 times x plus 3 all over 6. And then I have 23 times 18 times x plus 3. And multiply your denominators. 18 times 1 is 18. Now I'm going to go cancel what's common to the numerator and denominator. So in the first fraction, my x plus 3's cancel each other out. Here, I see that 6 goes into 18 3 times, so I'm going to reduce that part of it. And then over here, my 18's cancel each other out. All right, so let's start cleaning this up. So I have 4 times 18 plus, I'm at least going to multiply that 5 and 3 and get 15, because I still have that x plus 3 I have to distribute to in a minute. And then that equals 23 times x plus 3. So if you do this correctly, after you cancel, you should not have any denominators left. And now you're just left with a multi-step algebra problem. 4 times 18 is 72. Distribute to clear your parentheses, so that gives me 15x, and 15 times 3 is 45. Distribute, you get a 23x, and 23 times 3 is 69. On the left side, you should combine like terms. So now I have a 15x plus 117 equals 23x plus 69. I'm going to move my variables to one side, so I'm going to subtract 15x from both sides. That means I need to move my numbers to the other. That means I'm going to subtract the 69 to the other side. 117 minus 69 is 48. 23 minus 15 is 8x. So I have 48 equals 8x. I'm going to divide both sides by 8 and get 6 for a good final answer on that one. Next page. The one labeled, that should be labeled 3, is the exact same as the one we did before, so I'm not doing that one. 4 and 5. Okay, let's do number 4. So the first step said that you should factor any denominators. So this trinomial right here, I'm going to make an ACB chart and factor it. So I need factors of 8 that add up to 6. So that would be 2 and 4. So this factors as x plus 2, x plus 4. So my LCD is x plus 2, x plus 4. And I probably should have done that somewhere else off to the side, so I'm going to erase that so that I can keep this clean. I'm going to multiply every single term by my LCD, which is x plus 2, x plus 4. So I'm going to multiply these two terms by the first one. So when you multiply your numerator straight across, you get 4 times x plus 2, x plus 4, and then you have the x plus 2 in the denominator. Bring down your plus sign. Now we're multiplying this times that second term. So in the numerator you have 3 times x plus 2, x plus 4, and you have an x plus 4 in your denominator. And then over here I have 12x minus 3 times x plus 2, x plus 4, over x plus 2, x plus 4. Now I'm going to see what matches top and bottom and go canceling. So here my x plus 2's are gone. There my x plus 4's are gone. And this one, I'm going to cancel out both those. All right, so what do I have left? I'm going to clean this up a little bit. I have a 4 and an x plus 4. I'll distribute in a minute. I have a 3 and an x plus 2. And I have a 12x minus 3. Let's distribute and clear parentheses and do algebra and solve this. So that gets me 4x plus 16. Distribute, you get 3x plus 6 equals 12x minus 3. I'm going to combine like terms and get 7x. I'm going to combine like terms and get 22. All right, so I'm going to subtract the 7x over, and I'm going to add the 3 over. So then I have 25 equals, 12 minus 7 is 5x. I'm going to divide both sides by 5 to solve, and get x equals 5 for a good final answer on that one. One more. So this one has a subtraction sign, so you just need to be careful and make sure you distribute when you have subtraction. All right, denominators. That doesn't need factored, that doesn't need factored, that one does need factored. I recognize that one is the difference of squares. I can take the square root of each. So that factors is a plus 1 and a minus 1. So it looks like that's going to be my LCD. Your LCD is basically what all do you see in the denominators. That's what you need to multiply every single term by. So I'm multiplying every term by a plus 1, a minus 1. So when I multiply it to the first one, I have 2 times a plus 1, a minus 1, over a plus 1, minus 1 times a plus 1, a minus 1, over a minus 1, equals negative 2 times a plus 1, a minus 1, over a plus 1, a minus 1. Now let's see what's common to the numerator and denominator and cancel. And then the second one, those and that. All right, let's rewrite it and clean this up. So I still have a 2 and an a minus 1. I have a negative and a 1 and an a plus 1, and equals negative 2. I'm going to distribute the 2 to clear my parenthesis and get 2a minus 2. Your subtraction and negatives are the same thing, so I'm distributing negative 1 there. Negative 1 times a is negative a. Negative 1 times positive 1 is negative 1. I'm going to combine like terms, so 2a minus a is a. And for your numbers, I have a negative 2 minus 1 equals negative 3. I'm going to solve, and I'm going to add 3 over to both sides. And a equals 1. At least I think it does. However, let's check this. All right, so a equals 1. So back in my original problem, I'm going to plug 1 in. So I have 2 over 1 plus 1 minus 1 over 1 minus 1 equals negative 2 over 1 squared minus 1. All right, so when you combine like terms in the denominator, that gets me 2 over 2. 1 minus 1 is 0. And 1 squared is 1, and 1 minus 1 is also 0. All right, so we have two problems here. The problem is that when you plug it in and check it, you get a 0 in the denominator, and you can't have a 0 in the denominator because this is an undefined function. So that means that a cannot equal 1 because you would create an undefined function. So since a equals 1, but here it says it can't equals 1, this is actually no solution. So we will talk more about plugging them in and seeing which answers are not allowed in the next section.